Hi, this is Priyanka, working as Assistant Professor in SNS College of Engineering. Today, lecture series, we are just going to see the combinational logics in this digital principles and computer organization. Today, we are just going to see the concepts of decoder, interconnect, decoder, encoder, mux, demux. These are all interconnected with each other. First of all, let's see address 1, address 2, up to address k. Then data is sent to mux, demux, and then from this data is again sent to the decoder, that is memory bank. These blue boxes are called as the memory bank, and then it consists of mux, demux, and the data are sent to the decoder, first encoder, then it's decoded. Let's see decoder in detail. First is a definition, logic diagram, application, tree of decoders. First is decoder definition. Decoder definition, here if we give n 2 power n outputs, you will be receiving. If you give n inputs, 2 power n outputs will be received. Let's see an example. 2 power n outputs. Here your n value is 3. Let's assume that n value is 3. If we give 2 power 3, that is if it consists of 3 inputs, it will consist of 8 outputs. This is called as decoder, that is n to 2 power n decoder. Here the function is yi is equal to 1 if encoder is equal to 1 and I02, I1, I0, that is equal to I. Yi is equal to 0 otherwise. Here if you give 3 inputs, you will get 8 outputs. N inputs, that it gives 2 power n outputs. 1 hot outputs, only one output high at once. This is of only one output high at once. Here A1, A1, A0 are the inputs, whereas we can receive 4 outputs, that is y0, y1, y2, y3. This is 2:4 decoder. If you give 2 inputs, you will get 4 output, that is called as 2:4 decoder. 1 1 1 0 0 1 0 0. These are the input combination. Now let's see the table. It is A1, these are the inputs, that is 0 0 0 1 1 0 1 1. Here the outputs received is y3, y2, y1, y0. Here we get the diagonal ones. Decoder logic diagram. This is a logical diagram of the decoder. That is here y0 is equal to 1 if I2, I1, I0 is equal to 0 0 0 and enable is equal to 1. Here enable will be always available in each node. Decoder application, universal set, that is decoder comma R. Let's assume an example. We are just going to see the example. We are just implementing functions f1 of a comma b comma c is equal to summation of 1 comma 2 comma 4. Here f2 is a comma b comma c and summation is 2 comma 3, and f3 is a comma b comma c, summation is 0 comma 5 comma 6 with a 3 input decoder and OR gates. Here we are using a 3 input decoder and we are just using a OR gate. Here first OR gate consists of y1, y2, y4. It is f1. Next OR gate is y2, y3. That is f2. Finally f3 is 0, 5 and 6, that is y0, y5 and y6. Here the main diagram for this is we are just giving 3 inputs A, B, C, and finally we are just getting 8 inputs. From this we are just deriving an OR gate using the given function, that is f1. Here f1 is given as 1 comma 4, 2 comma 4, so we are using the y outputs y1, y2, y4. In such a way the remaining also will take place. This is an example. Next is ornamentals. Here this is 2 cross 4 decoder. Here the various inputs are AB, AB bar, A bar B, A bar B bar. Here Y is equal to AB plus A bar B bar. It is equal to AO. This one is B dash. Now we are just going to see example that we are implementing a 4 2 power 4 decoder with 3 2 power 4 decoders. This is an example for this is another example for implementing a 6 2 power 6 decoder with 3 2 power 3 decoders. Thank you.